2008, the then New Zealand Computer Society, but now called IITP, put out a report. And by the way, I told this to the Brits, they gave it to the Royal Society, and the Royal Society put out a report in January this year, which has changed education in the UK, right? Teachers did a report with the ministry, I think might have been hoping they'd say, actually, no, the New Zealand Society's not right. The report said yes, no, right? Actually, there's authors of both of those reports in this room. It's cool. So the ministry formed a committee called DTIP, and that's where I got involved. I had nothing to do with this stuff until then. Some recommendations were made soon. Curriculum was written in a matter of months. There was a symposium at the end of the year where no one quite knew what was going on, but there was a lot of chance for a little bit of training. The standards were registered in 2011. I tell you, people overseas cannot believe how quickly we've done this, and I think we're thinking we would have been nice to go slower, but we might have dropped the ball. I think we had a window of opportunity, we had to jump in. So yeah, it rolled out in February 2011. The exemplar was published in the middle of the year after everyone had been teaching it. The rolled out level 2 next year, which isn't that far away. Level 3 is going to roll out. We've had the 2 bits of training there, but one of the things I really want to acknowledge is a lot of this is people figuring stuff out for themselves and peer support and that sort of stuff. And I've got to go all around the country talking to groups and that, and I'm just amazed at the level of peer support. And if your area doesn't have a good group, encourage them to get together and do that. You kind of need a champion to make things happen like that. Also, Google gave us extra funding so we could get people who aren't in main centres here and give them more funding to get here. And we've got lots more people like that here as a result of that, so that's really cool. We're going to see some of those people, as Tanya mentioned, in a few years, and they're going to graduate. Google is going to see them in 2016, and I just want to acknowledge that they're playing a very long game here. They haven't even got Google stamp on these kids, they're just rising the tide, and when the ships all rise at the end, they'll pick off the ones that they can persuade to work for them. And I should mention there's been, the other main sponsor is Telligis. You'll see their posters around here. It's a local company that hires lots of people. But there are a lot of companies and all the universities have contributed financially to making this kind of thing happen, which is cool. Just for fun, we had a big earthquake right on the months that it was all rolled out. And of course, with a lot of support coming out of Christchurch, it's amazing anything happened. Although the interesting thing was, I think, performance of kids in Christchurch was actually better than usual. And because people knuckled down under a crisis, and also McDonald's is closed, I think. Sorry? The pub was closed. Year 13s? Okay. Teachers. That's the real timeline. My supervisor in 1985 was trying to make these things change, and suddenly we had that window of opportunity. Now, just to put things in perspective, and I have just spent a month and a half overseas, mainly in China actually, because they know they have no problem getting kids to do computer science. They just say, who wants to do computer science? And everyone says, pick me, what is it? You know, that's the advantage of having big populations that are highly motivated about education. But in the UK, they've got the computing at schools. Is anyone on the CAS mailing list? Yeah, you can join that if you want. So I was just meeting with Simon Hayden-Jones and Simon Humphreys, the two Simons. They kind of run the CAS thing and a lot of the curriculum changes that are happening there. And they said it's fine if New Zealand teachers, they sort of had a little thing, well, we don't, maybe if all 300 of them join, it might skew our stats, but they said it's fine if you want to join. You'll get oodles of, I mean, you think NZ's got lots of stuff, they've got oodles of stuff going on, but it's a bigger country. But they are going, basically they threw away the curriculum in January, and Google have put in actually less money than they did into New Zealand, but in terms per teacher, but you know, megabucks is an absolute value. The US are really struggling to make anything happen because they always struggle to make things happen. They do have some cool stuff happening in the final year, but it's kind of like scholarship exams. It's called AP, and that's about the best they can do. I'm working with some people there on a badge system that's outside the school system, and that may make some progress. Denmark have quietly been working in parallel with us, but instead of rolling it out to the whole country, they actually did it with like 2 schools with 2 teachers, which is quite sensible. And then I think in the next year or two, I think in 2 years, they're going to roll it out to all schools, but it will be very, fixed by then. Whereas with us, it's like, oh, let's all try it and share our best ideas. There's advantages both ways. I met with the SQA, the equivalent of the NZQA, and they, again, like us, the smaller country, they're a bit more agile, they're making things happen. And again, was very interested, basically. In fact, it's interesting because they have exams for computer science, and they're very envious of our projects. And I said, well, I think our teachers will be really envious of your exams. And they went, what? And the answer is, exams are great for some things and projects are great for other things, and it would probably be ideal to have both and a bit of each and all that sort of stuff. But qualification authorities tend to have rigid views of the world. Germany has had a whole parallel universe, and one of the main reasons I was in Europe is that they had a conference for the first time in English language where they tried to get people from around the world together who were doing this sort of thing. And everyone was going, what, you're doing this as well? And so there was a lot of sharing of resources. Their resources are mainly in German. And they've got 7 main Länder, I think, regions, and 2 of them have made some progress, and 5 are still fighting the normal political battles and so on. Israel has long been ahead of the game. They have had computer science for over a decade in their schools, but the people from Israel said, we're fighting a losing battle, the people are taking it out, politicians don't understand what it is, they can't see the point, which is bizarre because it's one country that really needs to keep itself up to date technically. And South Korea as well has got computer science in high schools. They've got an interesting system where only particular high schools offer it, and if you wanted it, you would send your kid to that high school. There's so many variations on it. But all of these people are really interested in what's going on in New Zealand, so we are being watched. They are on our mailing list. You probably, Simon Humphries posted something recently, I think, so feel free to say whatever you want, but they are taking a big interest in what's going on. Okay, the other thing that, in fact, David and I did earlier this year is we did a survey of teachers, and 91 of you responded. I imagine probably a lot of people in this room responded to that in January. It's an academic publication. It's just been accepted. It hasn't been made public yet, but we should release it. But the interesting thing is that, digital technology teachers, 50-50 female, which is very unusual for computer science. Tanya is the only female academic in our department, and that is not at all unusual to have. How many do you have at Victoria or Otago female? 2 out of lots. 14. Yeah, and it's really, these things. So it's just, in terms of role models, really important. Real lack of girls doing computer science, and I think we've probably said lots of times, and I can point you lots of resources, and we'll probably talk about it a bit later. But employers really like female graduates because of the qualities they bring to the job, interest in communication, people, things like that. They like boys that are really interested in communication and people and social things and so on as well. But obviously, the majority of computer users are female. Okay. The age group of, this is kind of not a surprise, but most digital technology teachers are over 50. And no one under 30 responded to the survey. They're probably busy twittering or something. But what I think is super cool is that teachers with this, and with many years classroom experience, have exactly that, lots of classroom experience. You know kids, you know how to make things happen, you know the system, you've probably got a little seniority in the school, which can often help make things happen as well. And so as a group, this is not a bad thing, but it's an interesting thing. And also, I think, we need to acknowledge that nearly everyone here is what is sometimes referred to as digital immigrants. Right? We're having to figure things out as it goes along. Most, I think now all of your students won't remember when YouTube didn't exist. Or Google. Programming. A few people had lots of programming experience, or were fairly confident, but we're almost 50-50 where digital technology teachers don't feel confident about programming, and that's how it is. And there's good reasons for that. You'll have other things you need to be doing, and not everyone's into programming. That's fine too. Hopefully, some of the and this is one reason that different people might use different resources. Some resources will help your students go step by step through things. I don't think it works all that well if you just say, look, there's all the resources, I'm off for coffee. But if you can engage, if you can try and work out what's actually happening there, that's a good thing. But you might err on the side of using resources that really have everything laid out. Whereas if you have a lot of experience, you could probably give students a more exciting and follow their interests more and so on, if you're able to basically bring a lot of experience into the classroom. And there are different ways of doing it too. So like in Unlimited, you bring in experts, right, to help with that sort of thing. And so the kids can do all sorts of really exciting stuff. And so that, yeah, lots of different models for doing it. You will hear about some of those as we go. Languages that people actually are familiar with. Yeah, lots of Scratch experts in New Zealand, which is a good thing, because that's a great way, sort of gateway language. Never heard that term before, but it sounds good. There are only two industries that refer to their customers as users. Yeah. But based on the languages, there's a number of people who have been programming for a long time. Beyond level 1, what people are planning to use, again, Python's become really popular. I think we'll probably see JavaScript take off quite a bit because the Code Avengers being a resource that matches the curriculum, and that's changed since the survey was done. Maths is useful for computer science, not rocket science maths, but just a little bit. And so it turns out most people have some kind of maths, but for a lot it was high school when they last really did it. And so another thing we need to acknowledge is that some of the stuff that we're going to do that's a little bit mathematical, and by the way, computer graphics, which is one of the new topics, it's actually just maths. It sounds really cool, and it looks really cool, but it's actually maths with pixels on the front of it. And it's a good way to entice students into it, but if they can't stand looking at numbers, then we'll do some of that and you'll get what I mean. But again, it's not so much, it's really just to acknowledge that this will be a big thing for some people. There will be concepts there that are new. Done that. Confidence teaching level 1, and this is the interesting thing. This is when, of course, at the end of the first year it came out, most people teaching it did not feel confident with it, and that's fair enough. But our goal is to, of course, skew this downwards, and it will come with time as we get more support. A really interesting one, and the people overseas echoing this. The reason for change, people said it's because it's better for my students. I'm interested in it and so on. Almost no one had a top-down directive to do it. This is a grassroots movement, and this is what's happening overseas too. Teachers want it, students want it, universities want it, governments go, we've already got computers in schools. Okay. Right, let's talk doing. This field guide that we've developed, it's written for students. Let's just actually, I'll quickly look at it rather than talk about it, but you'll be on to it in a minute. So, this is what your students will see if they go to the field guide. The version that we're releasing today, you will see comments in it like, fix this up. Is this the best way to explain it? Heidi, can you sort this out? Things like that. It's an early release. It's our summer project. We've just started. So it's just for your sort of private preparation and hopefully to give you a bit of confidence with these topics and so on. These, you'll see that the main ones that are available here are topics that appear in the 3.44 standard. And, well, just we'll go to computer graphics. They are one large page with lots of sections, and in the guides that are going to be put out, the ministry will say things like topics could include transforms or colour models or hidden surface removal. And so we're trying very closely to match the language that you'll see in the standards. Computer graphics people always do teapots. So like computer graphics. The system we're using is, because we've got about literally 30 people who have written bits of this, it's actually, if you're really interested, it's actually done on Google Docs. I wrote most of my bit while I was in China, and I was working with Yanina, who was in the UK, and Heidi in Wellington, and Jack in Christchurch, and another guy in LA, all on the same day. And we were typing in Google Docs, and then every quarter of an hour a script pulls everything out of it, formats it, and puts it here. And so it's not a beautiful website. First and foremost, we want to get text here that tells you what this jargon means and tells your students, here's the stuff you need to know, and then here is something you can do with it. But then we've got people like David and Ren, who we'll meet later on, and Timothy, who are contributing interactive material and images, and video is a big part of it as well. That will make it a bit fancier. The actual risk is if we put too much video and interactive, kids will just skip from video to video and not read the text anyway. We're very tempted to make it text only. They're going to have teachers looking over their shoulders, and you cannot do the work if you don't read the text. So in the end, watching a few videos is not going to give you a computer science qualification. You have to do stuff, you can't read stuff. It's about transform, so I've jumped into things. We'll do this much slower next time. But the goal is you're given the XY coordinates for one of the arrows, and you have to type in the next lot of XY coordinates for another lot of arrows. So if I change that, I'll try changing that to a 2. So it's that one there. Whoops, I changed it to a 20, and we're learning about coordinates. Right? Change it to 2, 2, 1, 1. Okay. Trying to make that green one move over there. In actual fact, for this particular exercise, you're going to have to double all the coordinates and add a couple of numbers to them. Right? That is pretty much up to the level of the standard. If your students can do that and talk about the issues and how much multiplication and addition has to be done to move that arrow, and show some screenshots maybe, or do some diagrams with different arrows or in a different system and so on. If you look at the bullet points in the standard, they're starting to tick those boxes and say, compares, talks about key techniques in the area. So key technique in the area of computer graphics is being able to specify where something is in the image. Okay. Using numbers. Renee.
So have you looked at the Khan and Human ones as well?
Yes, we have been through 7,500 online resources. We think, so we've taken the best of everything we can find online. Khan is one of the big ones. There are some problems with Khan, but sometimes we also link to some of the online ones. So sometimes you'll find, Khan, or and there's lots of others. So there's CS Inside is a big one. CS for Fun, and the CSTA, all of those sort of things. They have got amazing resources. And in fact, what we were hoping is we would find someone who'd just done exactly what matches the standard. And if they did, we'd just say, look, just do that. But we almost always had to basically adapt it so that it matched the standards. But quite often you'll find things that just say, just go and do this. And Khan is one of those. In fact, Khan is good for matrices. The next thing that comes after this is matrix algebra, and we say, just watch this Khan video. But there may be something we've missed, because we have only looked at 7,500 different things. Which, by the way, there's obvious places like looked at, and also Google searches, but also anything that anyone posts to the NZAC list, we've followed up on that. So if any of you have ever said this is a good resource, before you know it's in there, and also the doing. But if you spot something that you think would be cool and you haven't used it, click on there. Google what we want you to do is feedback often. So spelling mistake here, done. There's this resource on Khan that you've missed out that would be great to recommend. done. Okay, and Jack will be.
I want hundreds of these.
Yes. This book really is the wisdom of the masses. We're only going to have a few authors because we want to keep it consistent in style and things like that. But we are collecting anything that anyone will offer. So, and then we'll check whether we think it actually will be helpful to the standard and not confusing. There is some cool stuff that we've left out just because we think, look, you just can't go on and on, you can't do everything. Anything that's cool and relevant, there's a further reading section which is yet to be written in this particular chapter, but we have a list of things that say, look, if this was cool, we want to see a different view, have a look at these ones as well. Yeah, and you see lots of sections waiting to work. What else is there to say about the book? So it's written for students. Oh yes, there is a teacher version, so which looks like that. It's got green, so you don't accidentally sort of show the teacher version to the students. You see green, then you just don't. If you look through that, you'll see quite regularly there's answers to the questions. So the kids are told, try adding this number. For the teachers, you'll have to move it 2 to the right and 3 units up. Okay, that's the answer that the kids should be coming back to you with. Sometimes, the following, so for teachers, this introduces matrices, it doesn't assume that, and think about this in the curriculum and things like that. So we can put anything we want there, and we'll put acres of help. If you say, this needs more explanation, I need the answer to this one here, we'll whack it in, no problem, because we're assuming kids will never get access to it. Okay? Yes. Please take it and say, look, I'm not teaching you. They have, that's why we teach them in this chapter. And we tell them, if that's not enough, go to Khan Academy.
Maths seems to remove lots of things, right?
Yeah. Only the maths I use from school.
Yeah.
Remember, the graphics is just one of the topics.
Yeah.
For kids who don't want to go matrices, and there are plenty who won't, you steer them to a different topic. But this is
Yeah, that's a good point. In fact, let's just quickly talk through what those topics are. So we've got artificial intelligence, AI, which there's some statistics in there if you want to. By the way, each of these chapters will have multiple sections, and often 1 or 2 of those sections is more than enough to cover the standard. And so some of them are sort of softer, no maths, but a lot of talking and thinking and doing. Others, like the graphics, are hardcore maths. Do this matrix algebra. So it's super for students, yeah. Complexity and tractability, there's quite a bit of big numbers in there, basically. Things that will take billions of years and things like that. So students need to be comfortable multiplying by very large numbers. Formal language, won't be using maths that I've seen before, but if your kids are good at maths, they'll probably find this one a lot of fun. Has anyone done the Pirates Island thing from CS Unplugged, the running around islands and choosing? Yeah, that's it. Okay, it's basically that. Really easy. This is the other thing. It's really easy to do that with primary school kids. So a lot of these topics we've taught to primary school kids through the CS Unplugged. Really hard to teach to high schoolers. I don't know, the kids, primary kids, intermediate kids, they want to have a go, they'll try things out, that sort of stuff. High schoolers, it's like, well, do I have to, will it be an exam, is it a project, how can I undermine it? Yeah. But the other thing is that, thank you to some of the teachers here who have invited me into their classrooms, so I have actually taught some of these topics to kids in classrooms as well. Which I find very scary, but has had a big influence on what we end up writing here. So computer graphics is one of them. Sorry? It's completely free. It's not just free, it's open source. So if you don't like it, download it, change it, and put up another version of it. Yeah. Either for your kids, here's the local version, I've topped out the stuff I don't want to scare you with, or just they don't know what they're doing at Canterbury, here's how it should have been. That's absolutely fine with us. Yeah.
Thanks, it looks really awesome.
Right, cool, yeah. Actually, and the reason it's free and the reason that Jack can work full time on it is we got yet another grant from Google for this. Okay. There's actually 3 Googles funding us, it's not all the same person. So this conference is funded by Google Sydney, so please send your kids to Sydney and say thank you. The Computer Science Unplugged stuff, which is the big overriding project that I've been involved in, is funded by Google Mountain View, which is the mothership of Google. And this is funded by Google New Zealand. Yeah, because they're good guys. Google New Zealand is 2 people, by the way. Yeah. So actually we've got more people on this project than Google New Zealand's got. But yeah, no, all quite independently funded, which is pretty cool. That's one reason all teachers were funded for HS, because for the book, we're saying, a good way to get a whole lot of teachers together. And so the extra few of you who weren't funded are being paid for by the book funding. One less paragraph in the book, but lots more teachers here. Okay, another topic was computer vision. I'll talk about that, but that chapter's not really in a view to show you, so it's very out, as you can see. Network communication protocols, not about building networks, but the actual protocols, how these things communicate. And which, if you've got kids good at communication, it's actually probably an interesting one. Human communication. And then software engineering, which is very much about teams and projects and software disasters and things like that. So yeah, quite a variety ranging from quite mathematical to not. So basically, yeah, we did pick the best of all the resources that anyone's ever talked about. Or we had another project. The ministry actually did fund us, as some of you are aware, for the last couple of years to put resources up on NZDIT, and that's been one of the main sources. That, they're impenetrable. We thought we'd have like 50 resources, and there's 7,500. And so this is our way of saying, okay, this is how we would present those 7,500 resources in an interesting way. There is no programming in here whatsoever. Chapter 1, the introduction, explains this. I mean, you can go and read most of this, but I'll just highlight it. So, for teachers, right, what's the big picture? We've got, this is David's crazy calculator, this is cool. It's a really bad interface, and it's basically, it's slow and it's bad, and it's saying, this is what you get if you don't do computer science, right? And he's got 101 evil variations of it too. We haven't rolled out, I tell you. Yeah. So right down here, basically, if you want to do programming, here's some things that might suit you. So here's the Italio book, there's Code Avengers, Code Academy, Code Dojo, Try Python, Think Python, Code Bakery, all those sort of things are there. We probably haven't got the whole list, so again.
Code Academy.
Yeah. Sorry?
Code Academy?
Academy?
I think it's spelled right.
On the check.
That's right.
Academy.
Yeah.
Code Academy.
No.
No. That's,
Is that right?
yeah. If you do something cool, you have to spell it weirdly.
Oh.
Yeah. Yeah. And Khan Academy as well. So basically, if you want to learn programming, that's there. If you know of a really cool resource that you're using, click that feedback button. Jack can add it in. And the way he adds it in is he types into the Google Doc, quarter of an hour later. Well, actually, this one's frozen, the one that you've been given today, so it won't keep on updating because we don't want it to be moving under your feet all the time. But we will probably release new ones gradually over summer. And the goal is, by the end of January, there will be one that's sort of solid enough that you can show it to your students. It won't be complete, but it will have enough material in it to teach the 3.44 standards well. Yeah.
So my question is, when things get released, will it be hooked up to the one that you've given us?
Either it will replace this one here, or we'll certainly send an email to the NZDIT list. But after we get a couple of days of feedback from you, we'll probably go and change things. And then and yeah, if we make a major release, then there'll be it'll just appear, or we'll probably email and notify you. If it's not working that well, we might even get people to register so that you can.
Is there a plan to have a red? To have a
interesting, actually. Possibly, yeah. The other thing we're doing, of course, with the resources we've got, we can do. We're actually picking the low-hanging fruit at the moment. But Google in particular are really interested in accessibility. And so if someone was going to offer to sort that out in exchange for 100 coffee vouchers. Seriously, this is one of the reasons for open source. So you might take it and turn it into a read version, but even better if you just interact with us and we make it part of this. Yeah.
What about level 1 and 2?
Yeah, level 1 and 2. So there are good resources out there for level 1 and 2. Well, there's okay resources out there for level 1 and 2. And so we've made them a lower priority. But if we can keep on getting funding next year, so basically we'll go back to Google and say, this seems to be going well, we've had this many hits, and we might actually email teachers into a survey and say, do you think this is good, do you want more? And we can show that and say, how about we do a little bit more? We've got other ideas for funding as well. We could have a donate button and things like that as well, but I don't think schools would feel like pressing donate buttons a lot. But yeah, basically that's the plan for during next year, and so you might find bits of it starting to appear. It'll depend on the resources. Yep, there will be videos. In fact, I just got one of the first ones this morning. I might play it while we're in here. I haven't watched it yet. I saw a draft and I thought, oh yeah, good. Lots of interactive stuff. Open source I mentioned. And it's not available yet, but we are aiming to have it available as EPUB and Mobi, which means you can read it on Kindles and iPads and tablets and things. So it's online at the moment. You have to be online to use it. But there will be an HTML version that you can just download the whole 2 gigabytes probably.
Yeah, and a paper version as well. So
Oh yeah, and a PDF as well, yeah. The PDF won't be very... Originally we had a really cool PDF version, but the more interactives we put in, the more we thought, no one's going to want this on paper. Except maybe teachers might want to just print out the teacher guide and be able to carry it around with them or something like that. But yeah, you can download, well, you will eventually, slightly lower priority, be able to download the entire thing onto an iPad or a Kindle and just interact with it. And that's the other reason it might not look quite as flash as some web pages, but it's actually compatible with Kindles and ebook readers and paper and everything. And it all comes out of the same source files. So it's a very flexible system. Just so you know who's been at work, so yeah, I just tell everyone what to do. Jack's been working a lot on technical stuff. Heidi has done a lot of writing, and so she's a good person to ask about some of the stuff, and will be doing a lot of the writing. Yanina is one of our graduates. Some of you might have come across her. She's actually now a PhD student at Cambridge University, who got into computer science by accident. She was originally a journalism student, and so she's a great person for writing, actually. And by the way, her supervisor at Cambridge happens to be one of the Raspberry Pi people. So, which is funny because when I went there recently, I met with all the computer science at school people, and they said, "Oh, you should meet the Raspberry Pi people." And when I arranged it, he said, "Oh, hang on, Yanina's arranged for me to meet you as well," which is pretty cool. Warwick Irwin, who works for Google and is an amazing software engineer. And so we've got lots of people who know about the stuff who haven't quite got time to write it, but they're experts looking over it saying, you should mention this. I don't think this, that's a good way of putting it. I've introduced David. Rennie will meet later. I think he's been doing graphics all night. Simon did a lot of the early research on it, and then we have 3 teachers who have been helping us just with really initial work on it. 2 of whom are here, right? Patrick and Jenny. And so we've managed to persuade them to go through this very carefully, giving us very detailed feedback, and I assure you it is quite different to what it was a couple of weeks ago as a result of that. So thank you for that. And they're not related, by the way, not even the same island. And then all of these people have contributed something to it. And so a lot of the unplugged people, there's a couple of people I'm working with in Germany who are involved in the German curriculum. And again, the Brits and the Germans are looking at this and going, okay, this is almost the same as our curriculum. We'll add a couple of things into it and we'll be covered as well. So it's potentially could become more than just New Zealand, but at the moment we're only supporting New Zealand. A lot of the main people like computing inside and C is for fun people. They're basically on the team. Most resources these days in computer science are fairly open source and free, and so a lot of these people are happy to contribute it, but even better, we've got a good relationship with them, so it's not just that we used it and they go, oh, okay, it's nice to see it used, but it's actually like they're saying, oh, here's the source material, I'd suggest changing it like this because this bit never worked for us, or something like that. So we've got lots of people involved in a video production, hopefully 2 video productions for movies actually. Which actually, do you want to see the video? Okay. I'm a little nervous here. I like taking risks. I just give people things and say, do something interesting. So each of the chapters will have a video at the start. The idea is to say, this is what you might be doing when you're doing this chapter. Mainly 2 minutes. This one's kind of 4.5. But there will eventually a chapter as well. So it will be
Some people think that one day computers will be as intelligent as humans. Do you think that will happen? Do you think that will happen?
It hurts. Well, not really. I'm a robot.
Okay. What is the capital of New Zealand?
What kind of question is that? Everybody knows that the capital of New Zealand is Wellington.
Okay. What's 4 times 5?
Seriously, I'm not a calculator. I'm a robot. I'm capable of doing amazing things. I'm going to answer you just because I know that you are a human who is not capable of answering this question. The answer is 20.
Okay. Who is your father?
Tell me more about your family.
What? No, I asked you, who is your father?
Tell me more about your family.
What?
Tell me more about your family.
What?
Tell me more about your family.
At the moment, computers don't have the general intelligence of humans, but they can do some jobs that require specialised intelligence, such as playing board games, speech recognition for telephone answering, analysing buying patterns and making recommendations for online shopping, video games, logistics planning and scheduling, recognising what's in an image, intelligent controllers for driving cars. In this chapter, we'll look at some applications and also think about how to use software to be intelligent. We'll also think about ethical issues. Do we really want to build something that is as intelligent as us? Do we want to be giving our jobs to robots? Should robots be treated as equals?
Larry,
Yes?
will you be my pilot?
Sure thing, Martin.
us some feedback about, whether it's appropriate for high schoolers, but that's... Oh, beverage. Good spotting. Click that feedback button, we'll be on in a minute. Okay. So, yeah, use the feedback often. It's only a working draft, and more coming out, which we've done. Just before we go there, this is my catchphrase for this whole thing. Google wants lots more students coming through, Facebook wants your babies, all that sort of thing. But for me, the main thing is, the greatest tragedy now is so many young people never discover what they really want to do. And the goal is that if your students can work through some of these topics, that they might actually get really excited by them, that, they might get really engaged because it is something they would love to have done, but they never knew they were interested in. So that's the overriding thing. Now, I think the plan is that we're going to go... Oh, sorry, Anthony.
Could I have half a minute?
Half a minute, yes. Okay, go for it.
Thanks. Hi, I'm Anthony. I'll be talking about the programming standard tomorrow. I'm going to pass out a quick survey. If I can get some background information, that'll help me tomorrow. I'm also going to put a link on the board there, which is to the resources that I've got up online. It's just a couple of PDFs. It's nothing near like this. We don't get Google funding. I'm going to have to talk to Tim about how he gets Google funding. It sounds like a good idea. So there'll be a link on the board there to my homepage, a couple of PDFs, and a survey that I'll pass out. I'd also like to apologise. I'm not going to be about after 3 o'clock each day back at Bishop Julius for the socialising and the fun part of the eating. One of the things I do when I'm in Christchurch is visit my parents, and they're finally getting their house repaired. It's been a long battle. They've got 50 years worth of crap to move out of it. And so I've got stuff to do in the evenings. I'd love to be with you guys, but picking up dusty stuff is more fun. So if you're all interested in the programming standards, please grab this survey, fill it in, and then leave it in this box sometime today. At the end of the day, I'll grab this box and I'll have a look at it tonight. Thanks.
Thank you. Oh yeah, if you turned up late, important things. Max has the coffee vouchers. And if you haven't registered, the desk is upstairs where we're heading anyway. So just make sure you grab the things first. Where do we go next? Sorry? Where do we go next? Right, where do you go now? Okay, it's Lab 2, so up the stairs, and it's the large lab right just in front of you near the cafe where the robot was getting the coffee. Yeah, that's better. Yeah. Basically, we're going to have a bit of a play with the online book, and then have morning tea, and then do more.
Yes.
Just shut up. Watch this.
Yeah. We're going to give them that. Yeah. Bit of that too. Yeah.